So this is a 3-inch arch with the loading condition of 60 kN per meter and its left half and 2 point loads as shown in the figure, and it is asked to find out the horizontal thrust at each support. So horizontal thrust H and H at each support. So to find out, we have to find out the support reactions also, Va and Vb. Okay, now to find out Va and Vb, what we need to do, we need to apply equilibrium equations. So first the vertical equations, Va plus Vb is equals to the loading acting downward to 60 into 15, this distance 5 5 5 15, to 30 minus 15 is 15, 60 into 15 plus 100 plus 80. Okay, now the other equation is moment taking moment about point A or B is 0. Okay, let's say moment about point A is equals to 0. Okay, so what will be the moment equation? Vb into distance, so Vb into 30, which will be causing an anti-clockwise moment, other force other will causing clockwise moment, so this must be equals to 60 into distance is 15. This is the loading where it will be applied at 15 by 2 plus movement due to this 100 kilonewton, 100 into 15 plus 5, so 100 into 20 plus, so this is 160 not 80, this is 160 kilonewton, so plus 160 into the distance will be 5 plus 5 so this will be 25. Okay, so from this if we simplify this, we'll get Vb is equals to 425 kilonewton. Okay, now Va can be found out from this equation, Va, so which will be equals to 735 kilonewton. Okay, so both the values are coming positive, so both are acting upward. Okay, now after finding out Va and Vb, to find out the horizontal thrust, we need to take moment about point C is equals to 0. So moment at point C is equals to 0. Either consider left or consider left. So if I consider the left one, Va into the distance is 15. Va we already got 735. 735 into distance is 15. Okay, which will be causing an clockwise movement, other forces H, and this one will be causing anti-clockwise movement, so this must be equals to H into distance is height. What is the height? Is it given in question? Yes. So in question it is given this height is 10 meter. Okay, so this height H is given as 10 meter, so H into 10. Okay, so plus the loading condition is 60, so 60 into the distance is 15, 16 into 15 into 15 by 2, so 15 by 2. Okay, so from this only unknown is H, so we can get the value of H is equals to 427.5 kilonewton. Okay, now we, according to our question, we got the horizontal thrust. In some question it will be asked to find out the bending moment at any cross section. Okay, so we have to find out cross section here, bending moment, cross section here, bending moment. So at all this cross section, if we find the bending moment, then we can draw the bending moment diagram. So I will take an example to find out the bending moment. Let's consider this is the cross section X and X. So if I find moment at cross section X between A and C, what will be, considering the left one, what will be the moment? Due to Va there will be which moment? Clockwise moment. So Va, the value is 735, so 735 into the distance is X, isn't it? So 735 into X, then due to this H or due to this 60 kilonewton, what will be the moment? It will Va clockwise, due to 60 there will be anti-clockwise, so minus 60 into X by 2. Now due to this H also there will be anti-clockwise, so minus H into the distance must be Y. So at this value the height let's consider is y. Now this will be the bending moment at any cross section. If we know, if it in question we are told to find out the bending moment at a distance of x, if this value is given, x value is given, then we can find out the bending moment at any cross section. Okay, now if in your question it is asked to find out the distance or x where bending moment is maximum. Okay, if I consider this cross section x and we have to find out the maximum bending moment. Okay, so in that case, for maximum bending moment, then differentiation of this moment with respect to x, dmx with respect to x must be equals to 0. Okay, differentiation of moment at this cross section, if it is 0, then from this we can find out the value of x. Okay, so at that distance bending moment will be maximum. How? So if I differentiate this value, so this will be differentiation of 735x. What will be the differentiation? Differentiation dmx upon dx, this will be 735 minus 60 by 2 is 30 x square, so this will be 2x 2x. So this y value will also be known to us. How? The parabolic arch, this will y value equals to 4h by l square into x into l minus x. So if we put this here again, we can differentiate with respect to x. So this, there will be one equation is equals to 0. Okay, you need to solve it on your own. So from this we can find the value of x. Okay, so if I put the values of x, h and l here, this value will come around 4 by 3x minus 4 by 90 x square. Now if I differentiate this here, we will get minus h into dy upon dx. Okay, so I will get 735 minus 60x, h value is known to us 427.5, differentiation of this, so 4 by 3 minus 4 by 90 into 2x, so 4 by 90 into 2x is equals to 0. Okay, so from this equation the only unknown is x. Okay, so from here we can find the value of x. Okay, so calculation part you can do it on your own. Okay, so now this is a 3-inch arch problem where the supports are at same level. Let's solve a problem where supports are at different levels. So now there is a problem where the supports are at different levels. Okay, so this is a 2 meter, if radius is given, this in, then this is semicircular arch. Okay, and this or segmental arch we can say. This is another semicircle with radius of 4 meter. Okay, we need to find out the support directions VA, PV, horizontal thrust H and H, and along with that bending moment at any cross section or at point D or at E. Okay, in the question it is asked. Okay, so for first we need to find out the support direction VA and VB. Okay, to find them we have to apply equilibrium equations. VA plus VB is equals to 40 plus 60, so this is 100 kilonewton. Okay, so here as the two supports are at different levels, so we cannot consider or we cannot solve this problem as simply supported beam. Okay, however we can take moment about point C is equals to 0. So whenever there is an arch with supports at different levels, then we cannot consider it as a simply supported beam. Okay, so in that case when we have to take moment at point C is equals to 0. So if I take moment at point C equals to 0, considering the left side, okay, considering the left side, what will be the moment at C? VA into the distance is 2 meter, isn't it? So VA into 2. Okay, other forces will cause opposite reactions, so with equals to H into 2, radius of the semicircular arch, H into 2 plus this load 40 40 into which distance? This distance. So this distance will be, if this is 45, then this is cos 45, isn't it? So this will be 40 into cos 45 is root 2. Okay, so from this we got VA is equals to H plus 20 root 2. Okay, let's consider this is equation 1. Considering right side of the C. Okay, considering right side of the C, again we have to find out moment, which is VB into distance is 4. This must be equals to H into 4. H into this distance is 4 plus the load is 60 into this distance. Okay, so this is 45, this is also root 2. So 60 into this will be 2 root 2. So 2 root 2. Okay, so from this we get VB is equals to H plus 30 root 2. Okay, let's consider this is equation number 2. Now if I add equation 1 and 2, VA plus VB will be equals to 2H plus 50 root 2. We already know VA plus VB equals to 100. So only unknown remains here is H. So from this we'll get the value of H as how much we'll get? We'll get 25 into 2 minus root 2 kilonewton. Okay, if we put this value in VA and VB, we'll get VA is equals to 50 minus 5 root 2 kilonewton, and we'll get VB as 50 plus 5 root 2 kilonewton. Okay, now we got the support reactions VA, VB and the horizontal thrust. Now we need to find out bending moment at point D and D. So bending moment at D, MD will be equals to point at this point. If I consider the left side, the VA into the distance VA, how much we got? Let it be VA only. VA, this small distance, VA into this distance will be the moment due to VA. We can find out this if this is semicircular, but with this distance 2 sin 30. If this is cos 45, this is 2 sin 35. If this is 2 cos 45, this length will be full length, 2 minus 2 cos 45. This will be 2 minus 2 cos 45. Okay, this is VA. Okay, now H, left side of this cross section H. So negative moment H into the distance is this distance. This distance will be 2 sin 45, isn't it? So H into 2 sin 45. Okay, so this is the moment. If we put the value of VA and H here, then we'll get the value of moment at D as 4.43 kilonewton meter. Okay, now if I find out bending moment at point E, ME, so bending moment at point E, if I consider the right side part, this will be VB into which distance? This distance. Okay, what will be this distance? Full distance is 4 minus 4 cos 45. So 4 minus 4 cos 45 minus H into 4 sin 45. So 4 sin 45. Okay, so if we put the value of VB and H here, then we'll get the value of bending moment at E is 25.44 kilonewton meter. Okay, now this is the only difference here is when the two supports are at same level, we can solve it as simply supported beam to find the value of VA and VB. But when the supports are at different level, just consider moment at point C equals to 0. We'll get two equations. By solving them, we'll get the value of VA and VB. Finding out bending moment at any cross section is easy. We already know that. Okay.